Okay, this is the second video in a playlist that has to do with different types or the different classes of chemical reactions. And following up from the first video that dealt with synthesis reactions, in this video, what I want to do is address a special class of combustion reactions. And remember that combustion, by definition, is where we have the reaction of some kind of a reactant with oxygen. All right, so in this case, we're going to be reacting the hydrocarbons, which are a class of organic compounds that only contain carbon and hydrogen. And specifically, we're going to look at a set of molecules which are called the alkanes. All right, and the alkanes are listed here from a carbon compound called methane, which only has one unit of carbon, up to octane. So this molecule here is called methane, and the next one in the list is ethane. The next one in the list is propane. The next is butane. The next is pentane. Then we have hexane. Then we have heptane. And then we have octane. We see when you look at the formulas that the molecular formulas that in each case there's only carbon and hydrogen. So we want to look at the combustion reactions of these with oxygen. So we're going to start with methane. Methane's a gas, and it's going to be combined with oxygen. Now, what's unique about these reactions is that in every single case, the major products are going to be carbon dioxide and water. That's important for a student in chemistry to understand, because oftentimes when they ask you questions about these, they're going to preface the question by saying, okay, methane reacts with oxygen, and then they're going to leave it to you to figure out what the products are and to balance the equation, which is why we're in part why we're looking at this. So I'm going to give you some tips about balancing combustion reactions of the alkanes with oxygen. And we're going to start off with the odd-numbered example. So in other words, the example where there's only one carbon. All right. In that case, what you're going to do is go straight to the CO2, and you will balance the CO2 based on how many carbons appear in the initial compound. And for the odd number carbons, you're going to base that simply on the subscript in the formula. And since methane only has one carbon in it, then the CO2 is going to only have a 1 in front of it. We next go to the hydrogens, and we see that there's 4 hydrogens in methane. So we're going to need a 2 in front of the H2O here to produce 4 hydrogens on this side of the arrow. And that means now when we count the oxygen, so we do the O2 last. That's the key in balancing. In the following examples that we're going to do, the key is you do the oxygen last. So we see now on this side of the equation that there's 2 oxygens from the CO2. And because of the 2 in front of the H2O, there's 2 here. That's a total of 4. So that means that we're going to need a 2 in front of the O2. And so now this combustion reaction with methane is properly balanced. Now the next one I'm going to do is going to be propane. So I'll just write it down here, and that's going to be combusted with oxygen again. Propane and its combustion reaction with oxygen is classic. You see this over and over again in the textbooks and on exams and things like that. So it's a good one to practice and know. In fact, the ones that we're going to do here are really good ones that you should practice. And again, I'll go ahead and put little platforms out here for the balancing. Now remember my rule of thumb. This is an odd numbered alkane. There's 3 carbons here. So we're going to go straight to the CO2 and we're going to balance it based on what the subscript is in the starting compound. So we're going to put a 3 here. Then we're going to go to the H2O. So again, coming back to the propane molecule, we see there's 8 hydrogens in it. So we're going to need 4 H2Os on this side of the equation. 4 times H2O. So there's 2 H's in H2O. 2 times 4 is 8. And then lastly, we come back to the oxygen here. So you see on the right side of my arrow, there's a total of 6 O's from the CO2. And there's a total of 4 O's from the water. 6 and 4 is 10. So we're going to need a 5 here. Okay? All right, now the next example that we do, I'm going to just come back, I'll put a 1 here. Just in case you're having trouble, you're rusty with the balancing, then I want you to know there's a 1 here. There's not a 0. All right, the next one we're going to do is an even numbered one. So we'll do butane. And remember, these are straightforward in the sense that a combustion reaction, again, is the reaction of a reactant with oxygen. In the case of your alkanes, the products are always going to be CO2 and water. I'll put my platforms in. All right, and okay, now, in the case where you have an even numbered alkane, what I mean by that is that you can see the carbon has 4 carbons in this molecule. Then what you're going to want to do in the case of a hydrocarbon, where you're dealing with one of the alkanes between methane and actually all the way to decane, but in this video we're only going to focus up to octane. All right. In the case of a hydrocarbon, when there's an even number of carbons in the molecule, then what you want to do is automatically put a 2 in front of the compound. All right, and 2 times 4 is 8. Then what we do next is we go directly to the CO2, and we're going to put an 8 here. All right, to account for the 8 carbons that are now here. And then next will be the hydrogens. There's 10 of them in the molecule, but now there's a 2 in front of the molecule. So it's 2 times 10 is 20. So we're going to need a 10 in front of the H2O. 10 times 2 is 20. And lastly, as we did in the previous examples, we come to the oxygen. Now we see on the right side of my arrow, I've got 8 times 2, which is 16 O's for that. We have 10 times O here for 10 oxygens from the water. That's a total of 26. So we're going to need 13 O2s. All right. Now, my last example, we're going to go right to the heavy duty one. So we'll do octane. Put in my platforms. And these are gases. I just left the designation off up here. Let me just throw that in here. This is a gas. All right. All right. Now, so following my suggestion, we look at the carbons in the alkane. This is octane, and we see that there's 8 of them. That's an even number, so I'm going to put a 2 in front of this automatically. 2 times 8 is 16. We come to the CO2. So we're going to need 16 CO2s here. We come back to the waters. There's 18 of them in the molecule, but now that's times 2. So we're going to need 36. All right, and 18 is going to go here because 18 times 2 is 36. Now, what that's going to do is it's going to give us 16 times 2 oxygens, so that's going to be 32 oxygens here. And then we're going to have 18 oxygens from the water for a grand total of 50 oxygens on the right side of my arrow, right? 8 and 2 is 10, carry the 1, and so on. So that means that we're going to need 25 oxygens here. Okay, so rule of thumb with the alkanes. These are very important combustion reactions. All chemistry classes focus on them. You should practice balancing these reactions between methane and octane because of their frequency that they show up on tests. Remember the rule of thumb: when the carbon is odd numbered, go directly to the CO2 and balance accordingly, then move to the water, come back to the oxygen last. For the even numbered ones, automatically put a 2 in front of the compound, then you go to the CO2 and balance accordingly, move to the water, balance accordingly, and come back to the oxygen last.